Hey everyone, it's Microwave Sam, how are you? This video will be another workshop style tutorial where we're going to go over Introduction to Security Capture the Flag competitions and Quick and Dirty Python. Now, I'm not an expert on security capture the flag competitions, but I'll pass on what I know based on the workshop my friend gave and my own experiences from participating in several capture the flag competitions in the past year. In this workshop, I'll be treating it as a tutorial where I'm assuming you know basic programming knowledge, but I'll still go over the complete setup and what to do. I'm going to use Windows on my machine in case you do use Windows, but you can follow along with any operating system. First of all, let's answer big questions. What are security capture flag competitions? They are computer security contests designed for participants to compete while securing a machine or conducting software attacks found in the real world. There are two main types of CTFs, attack defense and jeopardy. In attack defense, every team has a computer or small network within a large network. In this competition, teams patch their services and develop exploits to use against other teams. You can get defense points for protecting your flag or hack opponents and earn attack points for stealing their flags. In the second type of CTF, Jeopardy style, there are various questions in security categories: cryptography, web, binary analysis, reverse engineering, steganography, the list goes on and on. Teams gain points for every solved task, and teams race to solve the most number of points. In this contest though, you don't directly attack teams. You just try to solve as many problems as you can and get the most points. In both types of CTFs, the team with the most points wins. And that's all there is to security capture flag competitions. Now let's get to Python. What is Python? Python's a general purpose programming language that's great for scripting, but many people also use it as their go-to language in security capture the flag competitions. Python's a very great scripting language, and it's good to use for the security capture flag. So that's why we're focusing on Python in this tutorial. Now, security capture flag competitions are available for everyone, and if you're interested, you can see upcoming CTFs at ctftime.org. I'll leave a link in the description, but now let's get to the real business of the workshop and talk about capture the flag competitions and quick and dirty Python. The first step is to get Python. Now, you might already have Python on your system, so you can skip this step if you already have Python, but for those of you who don't have Python installed, you can go to python.org/downloads, and there are two versions of Python to download, Python 3.4.2 or Python 2.7.9. You can choose either of the two, but I'll use Python 3.4.2 on my machine, and you can follow along if you want to use Python 3.4.2. So just select the version of Python that you want, and you can save it into a safe place, and you just wait until it finishes downloading. So in the meanwhile, you can go to this website, hackme.un-a.pk. Now, when you go to this site, it might be down because this site is basically an instructional website that my friend made to teach you how to go about security CTFs. Now, this website is specifically an instructional walkthrough for Jeopardy style CTFs, but the rules apply to nearly every type of CTF, and the way, the atmosphere, and the type of questions or the type of knowledge and type of exploits that you would need to create, you can learn from just listening up to this instructional walkthrough. So I'll go through some of the flags that we'll be trying to get from this website, and you'll learn about some of the process that goes about solving some of the challenges of a typical security Jeopardy style CTF. Now, we're going to go back to the Python, and we're going to open up the executable MSI file. We're going to run that file and get Python 3.4.2. Just going to hit next, leave all of these default, hit next, and it installs Python 3.4.2. Now, back at the website, let's just read the first part of the website. On the home page, it says explore this website and find secret keys. So keys look like this. Generally, keys have a key in the beginning, then some curly brace, and then some arbitrary string or arbitrary word, and then an ending curly brace. And this is the name of the key, your first key. So typically on a website, on a Jeopardy style CTF, you'd find different challenges, then you click one of the challenges and it bring you to a separate site or a separate, give you some files, and basically what you're looking to get is find this key. Now this is a bit obvious, of course it's obvious, it just gives you right off the bat, but this is showing you the general format of what a key would look like. So some of the techniques would be, let's say if the key was embedded somewhere on the page, then you'd find, doing Control F and search for key, and then you find all the instances of key, then you find, hey, there's your first key right over here. So that's a basic general way of finding keys, and then after you get the key name, then you copy whatever you have, right click, copy, and then give that key to the site where you just input the key inside and you get the number of points for whatever the question was worth. Let's go back to Python, hit yes on any prompts. It's going to copy, create new files, and finish installing. Now we're going to read a little bit more, and it says right click on a web page, view page source to see source code. Sometimes the developer left things behind or leaves things behind. And so a way to do this, I'm using Google Chrome, and basically on Google Chrome you can press F12 and opens up the web console. Now the web console contains the developer tools, including elements, sources, console, but you can see every single part of the HTML page over here at the bottom. But another way to look at the view on the page source, the page source is just the source code of the web page, is to right click and view page source, and then you see the whole page source of the website. Now one thing is we found our second key. So we see a key over here and it says your second key, and that's basically sometimes a key is embedded in the source code of the web page. So if this key was someplace else on the web page on the source code, just control find key, and then you see all the instances of key, and then you see your second key. So basically the general idea is sometimes when you view the source code you might find a key, and this is all the process of finding the keys to solve security CTF challenges. And this would probably fit in the category of something like web, where it's just a web related little thing where you can find a key. So let's get back to Python and finish that. Now we have Python installed, and we'll get to that later. But there may be some weird requests on the page. Watch for cookies on the web page. Sometimes they're used for authentication, and that's the general thing where the process of finding keys. So if we look back at the source code, let's see if we can find anything else. We'll just keep on reading. Sometimes it's not so obvious. Of course, this is very instructional, beginner friendly, so that's why my friend put keys as obvious as right in the page source, but you'll have generally much more complicated challenges than this. So don't think that security CTFs are easy by any means. So when you look at the page source and you scroll down, you always want to look at anything that's odd. So one thing that's odd is there's a comment for something called hidden.html. It says hidden. Okay, that's kind of suspicious. Well, let's see what it brings to if we put a slash hidden.html on the page. And so if we do that and press enter, it says page not found. So maybe we didn't find anything. Okay, but you need to whenever we come across web challenges like these are, you need to consider the possibilities. What would the challenge maker hide these keys? So a possibility is that a lot of web files come in the form of .php. PHP is another language that's popular for being a server-side language for websites. So instead of the extension .html, let's try PHP. And we enter. Okay, so we got to this new page and it says, who are you? Go away, you aren't admin. Okay, so how does that help us? Well, if you remember in the beginning, where let's go back to the page, HackMe, the main homepage, it says that you should watch cookies on the web pages. Sometimes they're used for authentication. Let me just hit out of the web console and go back to that page, hidden.php. It says that we aren't admin. Now, admin, of course, generally anyone knows that it's an administrator, and we need to check if there's some cookie behind this admin, because cookies are sometimes used for authentication, and admin is the most, it's the super user for authentication. So there's a good Google Chrome plugin, not a plugin, but a Chrome extension, cookie Google Chrome extension, and it's called EditThisCookie. Now it provides a easy to use interface to edit cookies, and this is one of the great Chrome extensions used generally. It's really good for CTFs, and it provides the ability to delete any cookie, edit any cookie, add new cookies, and check cookies. But if you didn't have this, then you'd look at the web console, pressing F12, look at the sources, or network profiles, resources. So in the resources of the web console or the web developer tools, you can find a section called cookies, and over here you can find one cookie. Okay, cool, it says user. Okay, and our value is unknown. So this is where you generally find cookies, even if you didn't have the Chrome extension. But let's get this Chrome extension, because this Chrome extension makes it so easy to edit a cookie, and it's provided in a really good, easy to use interface. So let's add this to Chrome. Add. It's just doing the checking, and now we have this little cookie mark at the top right. So if we go back to the page and click on that cookie, it shows the same cookies that are on the web developer tools. And in this user cookie, so this is the name of the cookie, and then it has a value, and the value is unknown. Well, if you remember, on the main page of this website, it said cookies are sometimes used for authentication, and the problem with this website is on the hidden.php it says to go away because we're not admin. So on the value, it makes sense to try to see if changing our value for the cookie to admin will work. So after changing the value, you want to hit the green check mark, and then you refresh the page, and that cookie will retain its value. So if we refresh the page, okay, it plays a video, and it also gives you the key, hack the planet. So if we look at the top right, you can see that the value of admin retained, and then because we had the value of admin, then the site loaded and it gave us our it authenticated with our admin cookie and gave us the next key, hack the planet. So now we found 3 keys, and it gives us some more files. So each of these keys in the real Jeopardy style CTF would be saved in a different challenge, basically. So each of these would be a different challenge, and you could get this key and then you submit the key. So it gives us the files, but we're not going to check this. It's hard stuff.zip and contains some cryptography challenges or some different challenges that we'll save for later. Next step is to go to About. Now, About, you can see that there's a picture of Allan, and Allan's my friend who made this website. But basically, it says, what else do you want to know? You're a 5th visitor to this page. Every 1,000 visitor gets a prize. So refresh, it says 6 visitor, and keep on refreshing. Now you can refresh this page 1,000 times to get the prize, right? The prize is probably key because this is a security CTF, but what's the point of that? You know, let's say that there was this challenge was changed up a little bit. My friend had some scripts running this page and visiting the page over and over and over again, and you could never get 1,000 because it would just be impossible to get exactly 1,000 because there were some bots visiting the page at the same time. But with the site as it is right now, you could technically visit the page 1,000 times, get the key, get the prize, and submit it for the points, right? But you can do this programmatically, and Python's a great language to do that. So we're going to use Python to crack this page and get the key. Okay, so let's open up Python. So go to search for Python, and we'll open the IDLE. So open that up, and this little shell pops up. So what we want to do is we want to create a new file, and it opens up to an untitled, very similar to a notepad. And you want to save this just to save it and get this saved. Save it to a convenient place. I'll call it about.py. Python files use a py extension. You want to save. So we're gonna use some libraries. So in Python, the syntax works as import. To import any library, we're gonna import the library called urllib.request. Now, what we want to do is basically we want to visit this page 1,000 times programmatically, and urllib is basically a URL type of library that allows us to do that. So first of all, we want to create a while loop, true, and we're gonna use this while loop to keep on going to this page until we hit 1,000. Or you can also do this because we know the general setup of this web page. We know that probably once you visit the page 1,000 times, you'll finally get a key. And so that's what we're going to do. So basically, urllib has something called URL open. And basically, what we're going to do is we're going to set a variable to this URL open and read functions, and then we're going to visit the page until the key appears on that page. So basically, I'll give you an example. I'll say x equals urllib dot request, and we're using the library. Then we're going to use a function called URL open, and the site name is hackme.un-a.pk/about.php. And we're going to use a second function on this, .read. So basically, let's just do a little print and print this out. We'll save this and run the module. Okay, invalid syntax. Okay, so one thing that I forgot here is quotes around the URL. And basically, right now, this is all we have. If you can't see, I'm importing the library, and I run it through the while loop, and I'm just printing whatever's on the page, print x. Actually, one thing is we should experiment before doing this while loop, and I'll show you what these two lines actually does. So I'm gonna press F5 to save. It's a shortcut for saving, and basically I get this long text. And if you find it interestingly enough, it's exactly the page source of the file, but it's all just jumbled into the lines without any particular space order, or the space order doesn't look organized, right? And if you look at it, 11th visitor, but on this page it says that we were the 10th visitor. So what actually happened was that we used this urllib library to visit the page and read it, and then we printed the variable, which is x, and then we printed the whole page. So that's basically what it does. So since we know that x contains the whole entire source code, think of it as a giant text file with the whole source code. So we know that everything on this web page, on this about.php, is in this variable x. So let us put that while loop back, and let's put a condition, right? So we know that once we get to the 1000th visitor, we'll get a prize. So a good way to do this is if we check if key is in x, then print x and then break from the loop, because we don't, since we're using while loop and it's going to be true, then it will run forever unless we have a halting state. So we use break to stop the while loop. Key is what we're looking for because we know the format of the keys on this security challenge. The keys are formatted in capitals, KEY, with curly braces. Now, one thing about Python 3.4.2 is that the format of URL open.read is in a format where you need to use something with B before the quotes key. So basically the reason for this is B represents a byte type of string, and X is in this format where you need a byte type of string to find. So that's my general understanding of that. So that's why we need to use B before the key. But if you're using Python 2.7.6, then you won't need this B. But for our purposes, we do need this B. So let's try to run it again. We do F5, okay? Missing parentheses and print. Okay, so one thing about Python 3.4.2 is I forgot momentarily that you needed parentheses. Not a big deal. We fixed that change. F5 and print. So basically what's happening right now is it's visiting the page until it finds key in the HTML. Okay, so basically it found the key and then it printed out the whole entire source code of the page at that particular moment. So what you see right now is that the prize is given and the prize is the next key. Key 999 problems, but a reload ain't one. So in security CTF challenges, the keys are normally formatted and given a word that's to poke fun in. It's just some random word, and it could be anything. So here I would submit this key 999 problems, but a reload ain't one, and I get the points for that challenge. And if we actually refresh the page, we'll see that you are the 1001th visitor to this page. Every 1000 visitor gets a prize. And if I actually reloaded my script again and ran this, then I would get the key again. But basically, I'd submit this key as it is. I'd copy whatever's in here, or even the whole key, and I get the prize, so a number of points. So that was that challenge, and so we've done 4 keys so far, and we're going to move to the next one. Now, one thing is, images are a really big thing, especially on a web challenge. So looking at this image, you see Allan, and if you open the image in a new tab, you see that there's nothing particularly suspicious about this, except that it's in a folder called images, and it's a photo called allan.jpg. So sometimes they have these steganography challenges where the image has been manipulated in some shape or form, and there is something within the images with the key, but in this case, this is a web challenge, so we don't have to worry about any steganography, any encoded keys within the image. So one thing you always want to check is folders on the site for the challenge. So we see that it's in an image folder. So let's just erase allan.jpg and press enter. Now we've gotten into the directory for images, and we see this second photo. Basically, there's a photo called shib.jpg, and if we click on it, we find an image with a key embedded in that image. Wow, such shib, wow. Okay, so we've gotten our 5th flag, and it is wow, such shib, wow. By the way, there are 10 flags on this site, so if the site's still up and you are doing this on your own, then you can try to find all 10 flags. But once the site's down, unfortunately, you won't be able to do the challenges on your own, and that's unfortunate. But you'll have an understanding if you watch my video on what security CTF Jeopardy styles are like, and it's always really satisfying to actually find the key and you cracked where the challenge maker saved the key or how they embedded the key somewhere, and you get some points. So I like competitions and I like these brain teaser type of problems, and it's fun to learn something as unique as security. So we found our 5th key, and we will go to walled garden. So this is the last key that I'll check. As you know, I said that there are 10 keys available on the site, but I'll only show 6 of the keys. Remember that there was a hidden.php where there's more keys in that zip file where you need to do some code analysis and try to crack the key based on the challenge provided. But for now, we're going to focus on this last challenge, and if there's enough interest, I'll show the answers to the last 4 challenges. But here's a good start to learning about Jeopardy style CTFs, and hopefully you enjoyed the tutorial. So basically, let's finish up this last key, walled garden. Solve 1024 CAPTCHAs to get a reward. So if I enter my name, Microwave Sam, and I submit, I get this CAPTCHA, right? And CAPTCHAs are one of those things at the end of a submission that sometimes they want you to submit some random amount of letters, and it's within an image that looks kind of funky to detect that you're not a robot. So that's what a CAPTCHA is. And then if you type in what the CAPTCHA is, B21D1, and submit, you solve 1 CAPTCHA. So you solve 1024 CAPTCHAs to get the reward. The reward will be a key. Now, one thing is, you could solve 1024 CAPTCHAs and get the reward. But why would you do that? It's a waste of time, and especially in a security Jeopardy style CTF, you only have an allotted time to finish as many problems as you want. Typically, they are from 24 hours to 48 hours, so you might not have all the time to waste to do this manually. So you want to find programmatic ways to figure out these challenges and get the points for those, finding the key. So one thing you always want to look at is source code again, but this time around we're not going to find anything suspicious with the source code. So we're going to X that out. And secondly, you always want to look at the URL, because the URL can tell you a lot of things. So what do we see in the URL? We see that it uses a PHP file, okay, and this question means that it's using a method and setting parameters. These parameters include my name, and I set my name to Microwave Sam, and it sets another parameter. Parameters are just variables, or basically names of the variable. And then we have CAPTCHA, in which it's an input of a CAPTCHA. So let's try to input the next CAPTCHA on the list. So if we do 14643B57 as shown in the CAPTCHA, and we submit that, then we see that the behavior of the link is that the CAPTCHA changes. So that's what I observe, and I take that to account. Now we can do some link manipulation with a similar script to the one that we use for about, and we'll get right to that. So if we look at the about.py, let's do file new and open up a new window and save this as walledgarden.py. So save it. I'll call it actually walled.py because I was messing around with another file, and I had the file walledgarden.py already, so let's save that as walled.py. Okay, so let's try to find an implementation to work to solve this problem. Now, one of the things I like to do is when I have a problem like this, then you always review the source code, because source code may always have some secrets. We know that we need to solve this problem 1,000 times to get the prize. So basically, we look at the link, we see that it has the CAPTCHA of the previously solved CAPTCHA problem. And if that's correct, then it says it's solved for our user, right? It gives us the name, Microwave Sam, CAPTCHA is equal to this. And if I paste the next CAPTCHA, well, let's try that again because I know there was a little refresh issue for me. But if I paste the next CAPTCHA, then it's going to solve 3 CAPTCHAs so far because it keeps track of how many CAPTCHAs this person, this name has figured out. So we know that it keeps a record of how many CAPTCHAs that you solved, and it's based on the name of the URL, the name of the username in the URL itself. So now let's try to do it with this next link, or see what we can do with this link. Manipulation of the link is always one of the key ways that you might be able to solve some of these security challenges, especially a web challenge. So if I copy and paste this next CAPTCHA, then it should solve the problem. So the next CAPTCHA, it should be 4 CAPTCHA solved. So if I copy this, just right click, copy the CAPTCHA, and you paste it inside the link, then it solves the problem. Now, when looking at the page source, we know that page source has some information that could be useful to us, and we know that the CAPTCHA is over inside the page source, but it has a unique header and ending tag. So that's useful to us because now we can find ways to extract the CAPTCHA. For example, if I can find a way to, let's say, find the source code, find where this pre tag is, and find where it ends, and then extract what's inside in between those tags, then I can hypothetically get the CAPTCHA, put it into the link, and then solve the next problem, and continue to do that until I solve 1,000 CAPTCHAs for my username. So that's the implementation that we're gonna try to do to solve this problem, and you can do it programmatically with a Python script. Now, it's very similar to about.php and how we're going to set up this Python script. First thing we're going to do is we're going to do the natural importing of URL lib.request. URL lib.request is the library that we use for about.php in order to read the page, visit the page. And visiting the page for this challenge is similar because all I need is the correct CAPTCHA and continually enter correct CAPTCHAs to figure out the challenge. So basically, it's a different version of the about.php challenge where I'm visiting the page like before, but I'm just inputting the correct CAPTCHA. So let's try this method where initially I input a CAPTCHA. And then, using the x variable, I'm going to set it equal to url.request.url_open. And in quotes, I'm going to copy this link because I know that I just need to visit the link. But each time I visit the link, I'm going to change the CAPTCHA. And that's hence why I named the variable with the name CAPTCHA. So I'm going to end this quote, so end this string with the end quote. And then I'm going to add to concatenate the CAPTCHA variable. Now, all that means is that I'm just going to add to the end of this link whatever's in that variable. For example, in this case, 3909 DDDA. And I'm going to print X to see if instead of solving 3 CAPTCHAs, I have visited the page, I inputted the correct CAPTCHA, and I end up solving 4 CAPTCHAs. So let's run this. I'm going to hit OK. Okay, there was an error because I forgot to put this CAPTCHA in quotes. When you put a string in quotes, these quoted variables are called strings, and they are just basically words or characters. So URL is also undefined. I forgot. URL lib is the name of the library, not URL. So I am going to type URL, and if you didn't see the code before, if you couldn't see it, then I'm going to zoom it in, and you can see I set the CAPTCHA to whatever the CAPTCHA is. I set URL lib.request, open up the HTTP link, and use CAPTCHA. Then I add the variable CAPTCHA from the line before this line, and then I read that to visit the page, and what is happening behind the scenes is I visited the page, and now I print that whole source code. So you can see that it works, and if you look closely, it says solve for CAPTCHA. So I know that I visited the page with the correct CAPTCHA, and it's solved. Okay. So now the next step is to find a way to extract the CAPTCHA so that we can continually put new CAPTCHAs in the link through a while loop, and then we can solve the problem. So let's just refresh this page. Let's go back to walled garden. I know that from the usernames are being saved and that I have solved 4 CAPTCHAs so far. So we have this new CAPTCHA called 1E5BD. And what I'm going to try to do is try to extract that CAPTCHA and input it into the URL. So basically, right now I'm going to statically hard code this CAPTCHA for the moment. But when the page visits again, well, in this case, if I run the program again, I'm going to solve 5 CAPTCHAs because, 4 plus 1, 5. Okay, so now I'm going to visit the page again and see if I can extract whatever's in that string, no matter what it is, and put it back into the CAPTCHA. So in this example, I'm gonna, let's see, how do we start approaching this? Alright, I'm gonna first split. So Python has this method called split, and it splits to whatever's inside that dot split function. So I'm gonna create a variable called b, and I'm gonna take x, which is the whole source code, dot split it, and I'm gonna split it as soon as it sees the pre tag. So basically inside these quotes I'm gonna put pre, so the caret pre, and caret. Oh, I call these carets, but they are less than and greater than sign, if you don't know what I mean by carets. So what this dot split method does is basically it splits the string into a list of strings, if I could say. And what I mean by strings, remember, if you forgot, it's just a list of words. So I split the list of words. As soon as x finds pre, then it's gonna make another split in the word. So we have 2 splits at the moment, 2 words in this list. And in this case, I also need to put b before this string because it's a byte string, and you require b because the format of x variable, the format of the source code, is in this byte format. So when I'm splitting and trying to find pre, I need to put b behind the pre tag. So basically, next up is setting a variable c, and I want to get to the point where it is after the b beginning. So in a list, in any programming language, normally a list starts from 0, 0 being the first part of the list, the first entry in the list. In this example, is the first word in the list, however long it is, and 1 is the second, and so on. So 1 is the second, 2 is the third list word. So I'm gonna print b to figure out what's happening within the code, because it's important to debug and understand what's happening within the code. So if I print b, basically it's printing the whole list, so there's no difference, right? But we will see that at the pre tag, it's hard to find in this jumbled mess, but we'll see there is a b right before the pre tag, where the pre tag was at, and so we know that this split function is splitting at that area. So basically it splits this long source code into 2 gigantic words, a jumbled mess, where b is B0 is the first part of this gigantic mess, and B1 is everything after pre. So now I'm going to make a variable c, now that we understand this code. So I just printed b for clarification on understanding. And I know that I want to get everything after the first pre-tag because we want something in between the pre-tags. So I make a new variable, I take whatever's after the initial head B tag, and then split it at the end pre-tag. So basically what's happening is that right now what's C is going to be the CAPTCHA, and then the second part of the word will start right at the less than sign of the end tag. So basically, if I print C, you'll see that it's the CAPTCHA, right? And then after that, it is where the pre-tag, the end pre-tag got replaced by B. So basically, we have two words. You can see the comma in between, where there are two words in this list. The first word is the actual CAPTCHA, and the second word is the everything after that CAPTCHA, or everything at the end tag pre in afterwards. So that's how this split function works. Hopefully you understand, but we're going to move on. D, I'm going to set a variable D equals the first word of C. So we're doing entry 0 of C, index 0, and index 0 of C is the first entry, the first word, which should be the CAPTCHA. So let's just print D to make sure that we know for sure that we have extracted the CAPTCHA. So I'm going to erase C, put D, and I'm going to run this program again. So now it prints out the CAPTCHA, but we have this B because in a byte string, since source code was in this byte type of format, we need to do something where we use CAPTCHA equals D dot decode. So we're going to decode this byte string and make it into a regular string, or make it into a regular word. So we're using CAPTCHA, the variable CAPTCHA, and we're basically setting a new value for CAPTCHA, if you understand how variable changes works. So we're going to set this CAPTCHA equals to basically D dot decode ASCII. ASCII is the type of decoding method we're using, and if we use decode ASCII, it's going to decode D, which is just the first entry in C. I know it's getting confusing, but bear with me. Basically, we're decoding the CAPTCHA, which is in byte string format, and making it into a regular string. If I print CAPTCHA, well, ASCII has two I's, so I made a mistake. I'm going to run this program again, and it prints the CAPTCHA in exactly the format that we want. So with that done, now we can combine all of this together. We know what the CAPTCHA is. We can extract the CAPTCHA from the source code. And what we're going to have to do is we want to loop this. So basically, every time I visit the page, a new CAPTCHA is generated. And so on each of these pages, I'm going to extract the CAPTCHA and then loop again and visit the page again with this new CAPTCHA. So we're basically visiting and inputting new correct CAPTCHAs 1,000 times until we get the key, which should pop up on the page based on what I've learned on about.php and how this challenge maker, how Allan has created these challenges. So it's all about trying to figure out how the challenge maker is making the challenges. So we're going to use a while loop. And we're going to leave this while loop, CAPTCHA at the end. And if we run this, it's going to run 1,000 times until finally, well, in this case, we're forgetting this step. So now that we have a while loop, we need a conditional to halt the while loop, because in this while true, it's going to keep on running because true is always valid. True always runs. So we need something to break the while loop. So in this case, we use a method or a technique that we use for the if statement of about.py, and we're going to embed an if statement after the x variable. So in this case, I'm just highlighting the points of understanding. I know that it might be confusing if you don't have a programming background, but basically what I'm doing is I keep on separating the source code into lists, and I try to pinpoint where at what point I want to separate it. So B separates it up to the pre-beginning tag, and so after that I have right when it hits pre, then it separates into the second word. So after pre, we know that the CAPTCHA happens. Then when I create the variable C, I select the second option, the second word, which is 1. So B bracket 1 bracket, and then I split it up to the ending tag. So now I have 2 words, the CAPTCHA and a word with everything after this ending pre-tag. And then D, I select the first entry, which should just be the CAPTCHA, and then I decode this CAPTCHA with .decode ASCII, which is a built-in Python function. And then now I'm just gonna loop into a while loop, set a conditional if B quote key, because we know that all of the keys are starting with capital key, is in X. So this should go after the X variable. So if B quote key is in X, then I want to print whatever the page is at that moment and break the loop. So basically I print parentheses X and then I break. So now it's going to do this 1,000 times until finally I've solved 1,024 CAPTCHAs, and then it's going to print the whole web page, which should show me the key. So let's run this program. Let's see if I get the key. And let's see if everything's good. Okay, so I am going to press F5, run the program. It's going to run 1,000 CAPTCHAs, importing each one by one sequentially, and then I get the source code. So now I see that the key is right over here, and I figured out my 6th key. So basically, this is the scope of the workshop. It's been a long workshop, and this has all been up to the introduction to security capture flag competitions, especially Jeopardy CTFs, and using Python to solve some of these challenges. Now, I've only touched the most top layer of security capture flag competitions. These are really basic challenges, but you can learn these challenges. I know that introduction to security capture flag competitions is tough, but let's go back to hidden.php. If we go back to hidden.php, there were some files, and if you want to try to figure out hardstuff.zip, there are a couple Python files and a couple of more keys, maybe the last 4 keys in this zip file. Then you can try to figure it out. Leave in the comment if you figure out what keys are in that zip file, and you can see if you can learn and try to implement solutions to these harder challenges. And those challenges include some exploit challenges inside. So basically, that is it for the tutorial. If the site goes down, I'll leave a link to the hard start zip in the description. I'll leave a Dropbox link so you can download and try to solve the last 4 challenges and get the last 4 keys. But thanks for watching, everyone. Hopefully you learned a thing or two about introduction to capture the flag competitions. I want to do something new and try to teach something more difficult and something not so well known as security capture the flag competitions, at least for non-programmers. It's not very well known. So thanks for watching, everyone. Please rate, comment, subscribe. Hopefully I did a good job doing this workshop, and you can leave any questions in the comments below.